This video is brought to you by Squarespace, the tool to use to make a website for your brand and grow your business. More on them in a bit. On the extreme outer edge of our solar system lies a semi-uncharted realm, a place as dark, remote, and mysterious as is possible to imagine. Out here, strange worlds lurk, far beyond the warming rays of the sun. Dwarf planets, frozen inside prisons of ice, worlds with orbits that take them swinging impossibly far away into the darkness. Minor planets that spin so fast their very shape has become distorted. Out here too, you'll find primordial objects, fragments of rock that date back to the formation of the solar system, ancient primitive asteroids forged into unusual shapes, slowly twisting through the void. Sounds almost like the stuff of sci-fi fantasy, doesn't it? A mysterious region of space filled with as yet undiscovered riches. Except the Kuiper belt is very real, and as we learn more about it, it's starting to become clear that it may be the most intriguing place in our solar system. In today's video, we're going to take a trip beyond the orbit of Neptune and examine the next great frontier of space exploration. If you were to climb aboard a TARDIS and fly out to the Kuiper belt for a bit of a poke around, the first thing that you probably notice is that it's very, very cold. Starting just beyond the orbit of Neptune at 30 AU from the Sun, the main body of the belt stretches all the way out to 50 AU, with 1 AU representing the distance between the Earth and our home star. That's billions upon billions of kilometers distant, so distant that the Sun would look like nothing more than a particularly bright star, so distant that the light it gave off would seem equal to only a full moon here on Earth. And that's just the main part of the Kuiper belt, the bit everyone agrees is a single structure. Beyond that lies something known as the scattered disk, a realm that stretches so far out it would make the distance between Earth and the Kuiper belt look like a gentle morning stroll. At its absolute most extreme, the disk is thought to extend out to a terrifying 1000 AU, a vast sweep of space across which the light and heat of our sun would get progressively dimmer until it began to feel like you were traveling through endless night. Now, not everyone agrees that the Kuiper belt and the scattered disk are a single structure. Some astronomers prefer to think of them as two distinct entities that just happen to share some common members. Sort of like how the Netherlands and northern Belgium are different nations despite sharing a language and a fondness for cheese. But if we do consider them together, then the Kuiper belt is simply one of the largest structures in our solar system. So big, only things like the sun's heliosphere can really compete. Which begs the question, what exactly is it? Well, in its most basic form, the Kuiper belt is a gigantic ring of primordial rocks and icy fragments known by many as the Kuiper belt objects, or KBOs. We say known by many because there are plenty of clever science dudes who intensely dislike this name, preferring instead trans-Neptunian objects. Since we went ahead and titled this video the Kuiper belt, though, we're just gonna go with KBO to make our lives easier. Anyway, the total confirmed count of KBOs currently stands at over 2,000, but this is thought not to be just the tip of the Titanic-sized iceberg, but barely the tiniest fraction of the uppermost snowflake sitting on its summit. If our current estimates are correct, the Kuiper belt is home to millions upon millions of objects. Of these, hundreds of thousands are likely over 100 kilometers wide, hundreds maybe over 1,000 kilometers, dozens maybe even bigger than the region's most famous residents, Pluto. By comparison, the asteroid belt between Mars and Jupiter has nothing close to this size. Even lovable underdog dwarf planet Ceres can't compete with the Kuiper belt's big daddies. Still, as they say, size isn't everything, there's also mass, and it's here that this great realm falls short. For all its millions upon millions of KBOs and its scattering of dwarf planets, the entire Kuiper belt is thought to contain significantly less mass than our home world, maybe a mere 10% of what this fat-bottomed beauty we call Earth is rocking. Although many think this wasn't always the case. Billions of years ago, the Kuiper belt may have contained up to 7 times the mass of our world, only for it to be rudely torn away by the outer planets. That's because the orbits of Jupiter, Saturn, Uranus, and Neptune shifted wildly in the early days of our solar system, shifts that ultimately caused the Kuiper Belt's undoing. In a bunch of hyper-complex gravitational interactions we're not even remotely qualified to even understand, the movements of Jupiter and Saturn shoved Neptune towards the outer edge of the solar system like a pair of partygirls expelling a disruptive drunk. As she rolled away from the planetary get-together, Neptune did what disruptive drunks always do. She went crashing into things, angrily hurling objects. Only these objects weren't half-empty bottles, but KBOs. KBOs that might have coalesced together into a planet one day if Neptune's gravity hadn't disrupted them, hurling some further out and sending others swinging inwards towards Jupiter to meet their fates. And all of this disruption is still visible today. Far from being a uniform ring of uniform objects, the Kuiper Belt is more like a strange family gathering of weirdos, eccentrics, and unclassifiable oddballs. So let's get to know them, shall we? Although there are quite a few classes, the basic division for KBOs can be summed up as exactly how much did Neptune's drunken rampage mess them up. For cold classical KBOs, the answer is not at all. These are the objects most like the Platonic ideal of what the Kuiper Belt should be. They all orbit in the main belt about 40 or 50 AU from the Sun. Their orbits are basically circular, they're perhaps only a little tilted off the planetary plane, if at all, and they behave like they should. Hot classical KBOs, by contrast, are still suffering the after effects of interacting with Neptune's gravity. Rather than obediently poodling around like their cold classical brethren, hot KBOs have weird eccentric orbits that send them zooming far away from the Sun before bringing them swinging back in. Oh, and just to be clear, the hot and cold definitions are strictly a way of differentiating orbits, not some sort of comment on whether you could roast marshmallows over their surface. But Neptune didn't just scatter the objects it interacted with, others it brought into its watery embrace. We call these captives resonant KBOs for the simple reason that they orbit in resonance with Planet 8. What that means is that for every time Neptune goes around the Sun, resonant KBOs likewise go around a set number of times. So maybe you have an object that goes around once every time Neptune completes 2 orbits, or 2 times for every 3 of Neptune's journeys. That last example wasn't pulled out of our asses either. The most famous KBO of all is a 3-to-2 resonance with Planet 8, beloved dwarf planet Pluto. Nor is our favorite space ball the only one. In fact, so many resonant KBOs are following Pluto's lead that astronomers now classify any with a 3-to-2 resonance as Plutinos. The category even includes another candidate dwarf planet, the ice-rich world Orcus. Yet another can be found in our next category, the family of KBOs that never gets close enough to be influenced by Neptune, the detached objects. The detached objects are the real weirdos of the Kuiper Belt family, the astronomical equivalent of your cousin who drops out of college to go live in a commune. Like hot KBOs, they have an unusual orbit, looping far, far from our star before drifting back in. Unlike their hot brethren, though, we can't blame Neptune for this. The closest detached objects get only 40 AU towards the Sun compared to Neptune's roughly 30 AU orbit. That 10 AU difference is roughly the distance separating our Sun from Saturn, and this is only those that get closest. Some detached objects, like the dwarf planet candidate Sedna, never came closer than 76 AU. At their most remote, they retreat to a staggering 1,200 AU distant beyond the edge of the scattered disk. All of which is why certain astronomers are convinced there must be some large mass object out there influencing their orbits. An object some believe is the hypothetical planet 9. Finally, there's a family of objects Sedna travels far beyond, those of the scattered disk. Like detached objects, those in the scattered disk tend to journey way out to beyond the main belt. The large dwarf planet Eris gets almost 100 AU away. Unlike Sedna, though, most of them return back to Neptune's rough orbit at their closest pass to the Sun, more victims of the giant planet's disruptive gravity. Yet, for all they may be grouped into multiple families, KBOs have some surprising things in common. One of which is that they tend to have a twin. Of the 2,000 plus known KBOs, a surprisingly large percentage are making their otherwise lonely journey with a companion. For the larger objects, this is often a moon. Eris and Orcus both have tiny moonlets accompanying them, as do Quor and Haumea. More interesting, though, are the binary systems. These are twin objects that both have such high mass that one doesn't simply orbit the other. Instead, they spin around a shared point in space, what's known as a shared center of mass. The most famous of these is Pluto and its moon Charon. But there are other smaller examples. Last and perhaps most interesting are the contact binaries. These are twin objects objects that have touched, transforming into a single shape. We got our first look at one in 2019 when the New Horizons probe visited Arakoth, sending back ghostly images of a red snowman-shaped rock turning in the darkness, a rock that may be the oldest and most primordial that humanity has ever seen. But while that concludes our tour of the KBO family, there's still one more official category, a controversial designation that nonetheless includes some of the most fascinating objects in our solar system. We're talking, of course, about the dwarf planets. Now let me interrupt this video to quickly tell you about our long-time sponsor, Squarespace. Look, you've heard me talk about them before, and honestly, if you're making a website anywhere else in 2022, well, that just seems a little bit insane, because Squarespace have all the tools you could ever need in one place. And not only that, but that place is super easy to navigate and make a website from. All you got to do is head on over to Squarespace. From there, the next step, for those of you that want to be quick, is to browse through their extensive selection of templates, and they make that super easy. They ask you, what's your website about? And you say, it's about whatever you do. And then they're like, well, you'll probably like these templates. And you're like, oh, I do. You choose one, boom, it loads up. There's some placeholder text, some placeholder images. You just replace those and you are good to go. There's a lot of other features you can use. For example, put a little email form on your site so people who could be interested in what you're selling or what you're doing can get in touch with you. Of course, that increases your inbound business. Of course, all the basics like analytics and blogs are included as well. Look, there really isn't a better place to make a website, so head to squarespace.com for a free trial, and when you're ready to launch, go to squarespace.com/geographics to save 10% of your first purchase of a website or a domain. And now back to today's video. In our entire solar system, there is only a single dwarf planet, Ceres, that isn't located in the Kuiper belt or the scattered disk. The rest lurk on the very edges of our solar system, a peculiar, magnificent class of worlds that are smaller than any of the classical planets, smaller even than the solar system's largest moons, yet many represent the next great frontier in space exploration. Thanks to a lack of visits, we know relatively little about most of them. Far too little for us to have made individual videos on each one, but we do know enough to give them a collective chapter in this episode. So in lieu of individual explorations, join us as we give these guys the condensed astrographics treatment. Ironically, the most important dwarf planet is also one we really do know a lot about: Pluto. Discovered in 1930 by self-taught astronomer Clyde Tombaugh, the former ninth planet is the first KBO ever witnessed by humanity. It also played a major role in our discovery of the Kuiper belt itself. Because Pluto is so small, far, far smaller than Mercury, people began to wonder if it wasn't a planet at all, but rather part of a class of icy objects beyond the orbit of Neptune. Astronomer Kenneth Edgeworth suggested this as early as the 1940s, but it would be Gerard Kuiper's 1951 paper that eventually gave this mysterious region its name. By the early 1990s, there were serious doubts that Pluto was unique. Doubts that culminated in 1992 when the second major KBO was finally spotted, the planetesimal known as 15760 Albion. With a diameter of only 108 kilometers, Albion isn't all that interesting in and of itself, but its effect on astronomy was comparable to that of Ivy Mike on Enoatak Atoll. It blew everything wide open. 1993 saw a slew of new KBO sightings that would eventually trigger the controversial decision to downgrade Pluto. Sightings that would soon also introduce us to some of the most intriguing objects in our solar system. Of these, perhaps the most intriguing of all is Haumea. Discovered in 2003 and named after a Hawaiian goddess, Haumea is a dwarf planet, albeit one significantly smaller than Pluto. While the king of the Kuiper belt rocks has a radius of 1,188 kilometers, Haumea, according to NASA, clocks in at just 620 kilometers. What it lacks in size, though, Haumea more than makes up for in weirdness. Rotating once every 4 hours, the dwarf planet is the fastest spinning large object in our solar system. In fact, it rotates so fast that the force has distorted its shape. Rather than looking round like a ball, Haumea instead appears strangely elongated, like some kind of giant space egg discarded by a cosmic chef. It's also the first KBO known to have rings and the first dwarf planet, although large asteroids like Chariklo likewise rock ring systems. Yet, it may be what we can't see that really makes Haumea a treasure. Deep below its surface, scientists think the dwarf planet may have once hosted an ocean of water, an ocean that remained liquid for up to 250 million years. If you're playing astrographics bingo, you've probably been waiting for what I'm going to say next. The subsurface ocean means it's not impossible that Haumea once played home to life. With the ocean today having long frozen over, it's doubtful we'll ever confirm this for sure, but the idea that a dwarf planet all the way out in the Kuiper Belt may have hosted liquid water raises all sorts of profound questions about where we may one day find microbes. If Haumea was once habitable, the thinking goes, so too could many other places in the universe. So yeah, Haumea, pretty amazing for a weird little space egg. Less utterly weird, but still pretty fascinating, is Makemake. Another dwarf planet discovered in 2005, Makemake has a radius of 715 kilometers, equivalent to 444 miles. It's also spectacularly bright, the second brightest KBO after Pluto, and while it's too remote for us to really study it, we do know it has snowfields of frozen ethane and methane on the surface. We know too that it sports its own moon and seems to have similar coloring to the former ninth planet. Yet even if Makemake is another potential Pluto, it still pales in comparison to its sibling, Eris. If you know the name, it may be because Eris is infamous. With a radius of only 20 kilometers, smaller than Pluto, but a larger mass, it was Eris's 2005 discovery that torpedoed Pluto's chances of remaining a planet. But we're not here today to rehash the is Pluto a planet debate. We already covered it in our video on, well, Pluto. Instead, we're here to marvel at objects like Eris and its moon Dysnomia. Objects so far from the sun, it takes over 550 years for them to make a complete orbit, meaning they were last in this position when England was fighting the Wars of the Roses. Objects so vast they can only be described as worlds. And what worlds they may be. Along with Haumea's frozen ocean, evidence is slowly emerging that many of the dwarf planets may be rich in liquid water, perhaps in the form of briny seas hidden deep in their interiors, perhaps in the form of cryovolcanoes oozing H2O across their frozen landscapes like lava. If that's the case, then it has stunning implications. Eris, Makemake, Quo, or even smaller objects like Orcus, or extremely remote ones like Gong Gong, may have once supported water, and they may even support it now. Sadly, it may be a long time before we get any confirmation either way, because while the Kuiper Belt may be the next frontier for space exploration, that doesn't mean anyone is planning to visit it. Right now, if we want to study the Kuiper Belt up close, there is a single active mission that we can rely on. New Horizons was one of the blockbuster probes of the 2010s, the mission that gave humanity its first close encounter with Pluto, sending back images that enchanted us all. The probe that conducted the first flyby of a primordial KBO, the weird snowman-shaped contact binary known as Arakoth. Now as we drift onwards through the nightmare of the 2020s, through a decade of pandemic and war, it remains a ray of hope, a chance to illuminate our cosmos further. With this mission recently extended by NASA into 2025, the New Horizons probe is currently doing a whole lot of important science on stuff like the heliosphere, which is great, but sadly not all that relevant to this video. But while the official end date for its mission is currently a mere 3 years away, that doesn't mean it'll actually shut down then. With a good supply of nuclear fuel, New Horizons is thought to be viable until at least 2040. That's an additional 18 years of swooping through the Kuiper Belt, and if NASA chooses to keep extending its mission that whole time, it could result in some awesome surprises. Currently, the ground team are using telescopes to hunt for new KBOs. Their hope is that they'll uncover something roughly within the probe's path, something New Horizons could study from afar as it zips past on its fantastic voyage. They may even, if we're extremely lucky, find a KBO close enough that New Horizons can alter its course and conduct a proper flyby, getting as close as it did to Arakoth in 2019. If that happens, it'd be like finding a cosmic Easter egg, a final bonus to finish out the mission, giving us a whole new insight into the building blocks of our solar system. And the best part? Any new KBO New Horizons encounters could be completely different to the cold, classical KBO that it visited in 2019. It might even be from an entirely different family. Yet as awesome as another close encounter would be, and we've got our fingers tightly crossed on this one, there's still something a little melancholy about it. With no new probes planned, whatever New Horizons sees next would truly be our final encounter with a KBO for the foreseeable future, the end of our micro-era of exploration within the Kuiper Belt. To be honest, it's hard to blame NASA. The belt is extremely far away and takes an extremely long time to get to. Space missions are expensive, and the agency would much rather concentrate on the epic stuff they've been doing closer to home, returning samples from Mars, putting humans back on the moon, and sending probes to explore icy moons with subsurface oceans. Compared to these clear-cut goals, a mission to Eris or Haumea or to investigate a bunch of Arakoth starts to look like a potential budget catastrophe. Luckily though, the lack of upcoming missions doesn't mean the end of our Kuiper Belt exploration. In fact, the greatest era of all may just be getting started. Less than 2 years from now, in 2024, one of the most badass telescopes in human history is going to open its eye atop a mountain in Chile and revolutionize everything. Known as the Vera C. Rubin Observatory, it will come equipped with an 8.4-meter mirror that will survey the entire night sky every few days, a mission known as the Legacy Survey of Space and Time. Now, 8.4 meters isn't the biggest telescope out there even today, and it does nothing on the upcoming 30-meter telescope or the extremely large telescope, both planned to come online in 2027. Where Vera C. Rubin will excel, though, is in its ability to process data at eye-watering speeds, flagging up hundreds of objects per night, generating an unprecedented number of discoveries. Among them are predicted to be swaths of new asteroids and near-Earth objects, countless supernovae, binary black holes, and neutron stars. And beyond Neptune, it's expected to find roughly 40,000 new objects that humans have never seen before. Try for a second to get your head around that. Right now, we're aware of roughly 2,000 KBOs, and just that smallish number has been enough for us to glimpse frozen dwarf planets, weird spinning egg things, and other stuff that's transformed astronomy. Now imagine how things will look once we've got a dataset 20 times larger. Imagine what sort of spectacular KBOs or even KBO families could be hiding out there in the dark, waiting to be discovered. The Vera C. Rubin, in short, is going to change everything. 10 years from now, people will look back on this video and laugh at how little 2022 dudes knew about the outer solar system, at how we never came close to grasping how truly magnificent the Kuiper belt is. And honestly, we hope that happens. Because if it does, it means we've got a future ahead of us filled with exciting discoveries. A future that we can't wait to be a part of. There may be no upcoming probes, it may not be on many lay people's radar, but as promised earlier, the Kuiper belt is the next great frontier. Now it's up to telescopes like the Vera C. Rubin to take us boldly where no one has gone before.